Electric charge. Charging by rubbing. When you take two non-metallic objects, such as a plastic ruler, okay, an animal fur, here's some animal fur, and rub them together, you get a very interesting effect. Before they are rubbed, let's just hold the plastic ruler over a bunch of bits of paper. Absolutely nothing happens. However, after you do the rubbing here with the fur here and the plastic ruler, you hold it over the bits of paper and they jump up. They are accelerated towards the ruler. You can see them kind of moving up like this. This is a great demonstration that your teacher can do, or frankly you can do at home. Since the paper bits were accelerated upwards against the force of gravity, right? Gravity's pulling the bits of paper down. What interaction was occurring between the ruler and the paper? A force. That's what causes acceleration. That's Newton's second law. Also his first law. It has been known since ancient times that when certain materials are rubbed together, they develop an attraction for each other. You can see this today when you take clothes out of a dryer. They're all kind of sticking together and you hear kind of like a little crackling noise when you pull them apart. In ancient Greece, people noticed that when thread was spun over a spindle of amber, the thread was attracted to the spindle. The Greek word for amber was electron. Hence, this force, big letters here, was called electric. People didn't stop there. They did further experiments that showed that dissimilar materials would attract each other after rubbing, while similar materials would repel each other. These effects would not happen without the contact, and later, given enough time, these forces of attraction and repulsion would stop. This led to the thought that something was being moved between the two materials. Later on, this was named charge. Because objects could be repelled or attracted, it was postulated that this charge came in two types to give rise to these two very different effects. In the 18th century, Benjamin Franklin, one of the founding fathers of the United States of America, named the two types of charge. He observed the attraction between a rubber rod and animal fur when they rubbed together. He named the charge on the rod negative and the charge on the fur positive. He could have named it in the other direction, which actually would have worked better, but we'll get to that a little bit later when we talk about circuits. But it's kind of arbitrary here. One could be positive, one negative. When you have a glass rod and you rub that by silk, the rod acquires a positive charge and the silk acquires a negative charge. If you put two rubber rods after they've been rubbed, so you've got two rubber rods, let's just sketch that here, two rubber, you put them close to each other, they're going to repel. But if you were to put a rubber rod after it had been rubbed by the fur and a glass rod next to each other, here's the glass, let's put a little G there, this is rubber, they will attract each other. Once again, further experiments proved that no new charge is created. Instead, it is just separated, because the positive charge acquired by one object is exactly equal in magnitude and opposite in sign to the charge lost by the other object. What's another way of saying this, where nothing new is created? Electric charge is a conserved quantity. The total amount of an electric charge in a closed system remains the same. It remains constant. It is neither created or destroyed. Just like energy was conserved, linear momentum was conserved, and angular momentum are conserved in closed systems, so is electric charge.